So this is a mini lecture on the relationship between little g, the acceleration due to gravity, and big G, the universal gravitational constant in the Newton's law of gravitation. So just to give some context here, the law of gravitation says that the force of the Earth on a mass at the surface of the Earth is proportional to the product of the mass and the mass of the Earth divided by the radius of the Earth squared, since the mass is at the surface of the Earth, times this universal constant g. And so on the one hand, we know from the law of gravitation that the force of the Earth on that mass is this expression. On the other hand, we know that its weight is mg from previous study. But we also know now that the force of the Earth on this mass m is its weight, which means, of course, that big G times the mass m times the mass of the Earth divided by the radius of the Earth squared has to be equal to mg. M cancels on both sides here, and so little g, to be consistent with what we said before, should be big G times the mass of the Earth divided by the radius of the Earth squared. And so if we do that computation, big G is 6.67 times 10 to the minus 11 Newton meters squared per kilograms to the minus 2. The mass of the Earth is 6 times 10 to the 24 kgs. The radius of the Earth is 6 times 10 to the 4, 6.4 times 10 to the 6 meters squared. And so that is, so you have a 6 here, and you have a 6 here, and you have a 6.4 squared. You have a 6.7 here, you have a 6 here on the top, and you have a 6.4 squared on the bottom. And so the pretty closely, these 6's all cancel out, and you just get the factors 10 to the exponent factors here. 10 to the minus 11 times 10 to the 24 over 10 to the 12, since you're squaring this. Well, that's roughly 10. Okay, look at the units. Everything cancels here except for kilogram to the minus 1 times newtons, and a kilogram to the minus 1 times a newton is meters per second per second. We know that from Newton's law, Newton's second law. F equals ma says that this is kilograms times acceleration, and so therefore if you divide by kilograms you get acceleration.